So I want to talk real quick about how you find vertical and horizontal asymptotes for each graph. So looking at this, we have this function here. We want to find the vertical and horizontal asymptotes. So to start with, we're going to talk about the vertical. And to keep this short, we just want to know where this denominator equals 0. So we got to ask ourselves, where does that equal 0? Well, using this, I'm going to solve for this. I'm going to get this equal to 1. So I get something that looks like this. Divide by 3. I get x squared equals a negative 1/3. So the question is, can I take the square root of a negative 1/3? You can. You just get a non-real answer. So there are no real zeros for this. So that means there are no vertical asymptotes. So there are no vertical asymptotes for this. That is usually the part that's easiest. The part that's hard to recognize is to understand where the degree in the numerator and denominator vary. Well, if you look at this and you compare them, the numerator is a degree 1. Okay, the numerator is a degree 1. The denominator is a degree 2. So the denominator's degree is bigger. So if the degree in the denominator is bigger, then this right here is going to be your vertical, or excuse me, your horizontal asymptote. Now, horizontal asymptotes are a little bit different than vertical asymptotes. A horizontal asymptote is something that you can cross, okay? But a vertical asymptote is one that you'll never cross. So what you need to just know is that this vertical, since there's no vertical asymptote, there is this imaginary line here, even though the line's already drawn, that when you graph this, if you do graph this, that the line will apparently try and get closer and closer to. Okay? Now, if you want an actual sketch of this, what it's going to look like is something like this. What it looks like is something like this. Okay, and again, what you need to know is that a vertical asymptote you never cross. A horizontal asymptote is more of a guideline. Okay? Because an asymptote in calculus we talk about specifically describes how a function behaves over time. Okay? And what this does is provides a guideline that sooner or later it's just going to get closer and closer to that asymptote in both directions. So let's take a look at this. This next one, if we look at the denominator, we're looking for where that's equal to 0. And you can tell that that's factorable, hopefully. So we have this expression So we have two different answers, plus or minus 1. So that means in terms of a graph, these imaginary lines that this graph will never reach. Okay, so these lines will never be reached. Those are your vertical asymptotes. Now we have to talk about the horizontal asymptotes. Now if you look at this, you can see that both the numerator and the denominator are degree 2. Okay, this first part, the numerator, has a degree 2 in it. The denominator has a degree 2 in it. So they're both degree 2. So how do we deal with that? Well, I said it's a lead coefficient over a lead coefficient. Well, what's the lead coefficient in the numerator? Well, the lead coefficient in the numerator is 2. What's the lead coefficient in the denominator? It's 1. So my horizontal asymptote is this line y equals 2. So in terms of what this looks like something like this. Now if you were to plot points, this looks like a lot of stuff going on here and trying to figure out how this graph would look. So if you look at 0, you would get 0 over something. So this point would be on the graph, and I'm just plotting points. And if I started picking numbers, it would be a positive over a negative between here. So it actually goes down this way. And for the rest of the graph, it looks something like this. And I'm just looking at the book. And the way that you could get this is by plotting points or using your graphing calculator. But again, all this is asking you to do is recognize where these asymptotes are. But this is just what the picture looks like. So, looking at the next one, we're not going to do anything. I have the graph here. You don't have to graph it. I'm just going to talk about the vertical and horizontal. So very quickly, I'm going to talk about horizontal right away because that's identifying degrees. We have a degree 2 and another degree 2. So that means that they're the same. So we're just describing a lead coefficient over a lead coefficient. So that would be 1 over 1. So that means that there is a vertical asymptote or horizontal asymptote at 1. So you could draw that. You don't have to. It's not asking you to do that. So what we need to do now is we need to describe where the vertical asymptotes are. And the way that you do that is you have to say, well, let's take a look at this function a little bit closer. And I'm going to factor both the numerator and the denominator. So if I factor the numerator, I get x plus 2, x minus 1. And you might say, well, aren't we just looking at the denominator? Why am I going to factor the numerator? Well, you'll see in a second. Okay. And in the denominator, if I factor it, I get x plus 2 times x minus 3. So this is how it's factored so far. Now the question is, what does this actually equal to? Or what does this function have for a simplified value? Well, this is the exact same thing as, if I cancel out these two terms, x minus 1 over x minus 3. So we're simplifying this as much as possible to describe this. So really this is the exact same thing as this. So this x plus 2 is really not needed. Okay? So when we talk about, well, negative 2 wouldn't work, well, it wouldn't work, but it wouldn't produce an asymptote. That would be the result of some number just not working in a function. This is really what this function is equal to when you reduce it as much as possible. Okay? So the question is, where does this have a vertical asymptote? And it turns out that if we looked at this, they still have the same degree if you drop it down to a degree 1. So I really should have looked at this horizontal one here, but it turned out to be okay. So where does this equal 0? Well, it equals 0 at x equals 3. Now, if you have these things cancel out, that doesn't mean that there exists a horizontal asymptote or vertical asymptote there. It only happens if they don't cancel out. Okay, that just means that you're adding something on that doesn't have a vertical asymptote to it. So this right here is where your vertical asymptote is on this graph. In the last video, I think I'm going to talk about the two specific problems using these word problems for the homework.